Thanks, Wendy, and a good afternoon to everyone. As Wendy said, I'm Tony Bergantino. I'm the director of the Wyoming State Climate Office, the Water Resources Data System. And welcome to the November webinar. And this briefing, it's a collaborative effort between my office, the University of Wyoming Extension, and USGA Northern Plains Climate Hub, US Geological Survey, and the National Weather Service office in Riverton. And we'll be looking at, as usual, climate, drought conditions, stream flows, forecasts and outlooks, and then we'll have a bit of an overview of the National Weather Service's probabilistic snow total tool. So on to the latest drought map, fresh from this morning, reflecting state of conditions through Tuesday, which was the 19th, I think. First thing to note is that after 4 weeks, that D4 or exceptional drought that was in the northeast was improved to D3 or extreme drought. We did have some continued degradation in the southeast and parts of central Wyoming. However, thanks to some precipitation that fell earlier in the period, we were able to upgrade conditions in southern Carbon County to D0 or abnormally dry, that yellow blob. And in addition to the D4 improving in the northeast, a large area of the surrounding D3 was upgraded to D2 or severe drought. Well, drought conditions 1 year ago over here on the left, they remained pretty much the same. The 1 year ago map remained about the same this month as it did last month during the last webinar. Currently, though, the map on the right is still completely covered with one of those D categories, although we did at least end a 4-week run where the entire state was in drought. Drought being when the state is in, or an area is in D1 through D4. I'll just point out again that yellow on the map, the D0 category, is not actually drought, but is abnormally dry conditions. So here's a quarter century worth of drought levels in Wyoming, the percentage of each, percentage of the state in each of those categories. Currently 98.3% of the state is in drought, which is actually down 1.7% from the last webinar. On the far right, you can see the increase in the D3 that we've seen in the last month or so, but at this scale, it's getting a bit difficult to see the weekly changes, which actually have improved just slightly. So let's zoom in to the 2020 to present. So here the drop in the area of D3 or extreme drought, as well as the more modest decline in the moderate drought or the D1 is more visible. And while there has been a decline, there is still 22.25% of the state in D3 or extreme drought or worse. That is down just over 1.5% from the last webinar, though, so that's some silver lining. You can also see the exit of the D4 exceptional drought, and these white arrows, those show the occurrences of D4 that we've had through the last 5 years or so, although you really have to squint to see the previous two, especially the one in 2021, that middle one. While the area covered was less during those previous two D4 occurrences, their duration was about 3 times as long. Both of those were about 12 weeks duration compared to the 4-week period that we saw in 2024. There's a new little thing here. It's a feature that we've made available in the latest version of the Water and Climate Explorer, which was the latest version came out about a month ago. I've said quite a few times that Wyoming's a big state, which means one area may be experiencing, say, extreme drought, while another may not have any at all. And sometimes even at the county level, the drought timelines may not be sufficient scale to see what's really affecting your little area. So with this tool, you can click on any spot in the state, or really the country for that matter. I chose a spot right in the center of Weston County where that little red square is. And then you get this chart here on the left showing what level of drought was experienced there week by week since the beginning of the drought monitor in 2000. It's a bit different than the previous two timelines, since those show the amount or the percentages of an area in each category week by week. But at this level, the chart just shows the category being experienced at that cell. If there is more than one category in the cell, the chart shows the category with the greatest area. And those cells are about 4 kilometers by 4 kilometers. So it's a pretty small area. If you do highlight an area on the chart, like I did with the rectangle here, you can zoom in and get a specific time period that you want and see the detail. And this chart down here on the lower right shows what happens when you zoom into about the last 5 years. And this tool can be accessed under the drought category of the Water and Climate Explorer at the URL down here on the lower left. So let's go on to precip. 2-week view. Much of the state is at or above median, with much of the east being well above median. And the exceptions in the state are the western tier or so of counties, along with the Bighorn Mountains and a bit to their east. So going back 90 days from, say, mid to late August to present, we do see a bit of green on the map and a bit more gray, indicating median to slightly above median precipitation. Most of it's on a swath running southwest to northeast, along with a patch in the eastern eastern Bighorn Basin. Much of this is from a few good storms we had a few weeks ago. The rest of the state, though, is below to well below median, those dark red and orangish colors, especially in the far west, the southeast, and then the Bighorn Mountains, and again extending down into the Powder River Basin a bit. All right, look at the 2 years. Here's the water calendar year precipitation totals. These are as a percent of normal. On the left, we have the water year, and you can really see that diagonal swath sticking out here, making its run from Uinta up to southern Campbell counties, and then in the far west corner or northeast corner of the state. The Bighorn precipitation does not stand out as much at the water year as it did on, say, the 14-day. On the right here, we have precipitation for the calendar year, which is still from January 1. So we're getting about almost 11 months of precip total here as a percentage. It does show a bit better shape compared to the map I showed during the last webinar. Sweetwater County, surrounding areas have had some improvement in the last month, but the rest of the state is below normal. So here we go to the standard precipitation index, the SPI. It's showing quite a bit of near-term wetness in the state at the 30-day period here on the upper left. The exception being the northwest. The diagonal swath is standing out here again, as it does in the 60 over here on the upper right. Here, though, the influence of that prolonged dryness that we had prior to the precipitation is dominating, and the storms only bring the diagonal patch to about normal, while on either side you got that extreme dryness showing still. 1 year down here on the lower right, we lose all the influence of that recent precipitation, and we see the longer term dryness dominating the northwest, along with about the eastern half of the state. Okay, 2-week temperatures, nighttime temperatures on the upper right now have been below freezing statewide the last 14 days. It's been coolest in the west and higher elevations, as one would expect, and warmest on the eastern plains, again, as would be fairly obvious. Departures from normal down here on the lower left, we have the southeast seeing the greatest departures, up to 5 degrees below average. Close second is southern Carbon County and a little bit in the Wind River range. The Bighorn Basin, as well as the northeastern, central plains, basically all but Laramie County saw the greatest departures, with some of the northeast and parts of Platte County seeing positive departures from average about 5 degrees or more above. Remainder of the state being generally about average. Daytime highs, looking up here on the upper right again for the actual temperatures, still above freezing the last 2 weeks, except for the higher elevations in the Medbos, Sierra Madres, Bighorns, the Northwest. Eastern Plains, again, the warmest, coming in around the lower 50s for much of the region. And again, the West was coolest, with highs in the 30s, low 30s to upper 30s, depending on elevation and location. Down on the lower left corner here, we have the departures from normal again, and we can see the state is somewhat divided north-south into 3/3. with the lower third seeing the greatest negative departures, i.e. that's the most below normal. You can see that purple area here in the Green River Basin where temperatures are up to 10 degrees below normal. This warms up a bit as you go east, but from there, but still with departures on the negative side. The middle third of the state was generally about normal, while you have the northern tier about 7 degrees above average, with the greatest departures on the positive side being in Sheridan County, and then on the eastern flanks of the Bighorns in northwestern Johnson County. Soil moisture, despite some snows, which did soak in places, my grass actually did start turning green there for a little bit right after the snow started melting. It was fairly short-lived though. Not a lot of improvement on the soil moisture map in the last 2 weeks. In fact, for the most part, there have been degradations, unfortunately. A few exceptions are down here in the southeast. Along with that area on the Goshen Niobrara border, which did see a very little bit of improvement going from the below the second percentile to the second to fifth percentiles, but otherwise conditions still not good. All right, basin snowpack. These are the numbers by the basin, all still under median still. Madison Gallatin up in the far northwest, and the lower Green in the southwest they're doing the best at 95% of median. The Sweetwater Basin in the central part of the state is next at 94%, and then you have the lower North Platte and the Tongue rounding out that top five at 93%. As usual, Belle Fourche, South Platte, and Cheyenne Niobrara doing the worst. Belle Fourche and South Platte are at, well, South Platte's at 50, and the Belle Fourche is under the 50% of median, while the Cheyenne and Niobrara comes in not much better at 55%. Still early in the season though, so these numbers do fluctuate quite a bit from day to day. Now, while the last map showed it by basin, this is more of a aerial, AREA, not from the sky, but an aerial extent of snowpack across the sky, across the state. And it shows a bit more detailed look at the snowpack by area rather than lumping it together for a single number for one basin. And the areas above median in that purplish color are mostly confined to the lower elevations, while the high elevation snowpack is below median in most places. The lower elevation snows are much more transitory and can come and go more readily. Much of the soils around the state currently have frost, with the exception of the far northeast and a few other areas. So infiltration, if there is any melting, is not as likely. And then we'll finish that with the frost depths. As I said, one more here. These are just various stations around the state that we have soil moisture and soil temperature probes at, so that we can come up with a depth of the frost just by figuring out between what depths you have the freezing mark. And up in the northeast, you can see most of the soils there haven't been touched yet. A lot of zeros up in the corner, but then as you start coming down to the south and west, you start to see numbers there. That number is the depth in inches where the frost line is. Laramie, the Elk Mountain Station, a few other areas are still frost free, but by and large, most of the state is starting to see frozen soils. But it is the 21st of November after all. And I think, yep, with that, we'll go to Aaron Fiaschetti, who is with the USGS, and he'll give us an update on surface water conditions. Aaron?
Thank you, Tony. So here we're taking a look at a screenshot of the National Water Information Dashboard, which displays real-time data for today compared to the median daily, or compares the daily average value for the day. The green is what's considered normal. That ranges from the 25th percentile, which would be a lower flow, to the 75th, which is a higher. Your central tendency would be the median there. And then the oranges and reds are the below normal to much below normal, which would be below the 10th percentile, and then a red would be an all-time low for the day. So we're seeing a fair amount of normal conditions to moving to much below normal, with sites up in the park, and then coming off the northern part of the Wind Rivers showing some pretty low flows for the day. We're coming into ice right now with some colder temperatures, so you'll see a fair amount of gray sites that reflect either something that's in ice and the stage discharge relationship doesn't work anymore, so we have to take that offline for provisional data, or it could be a seasonal site. So in general, the flows are kind of tend to be a bit below average right now, below the median across the state. So taking a look here to the next slide, we're just looking at a 28-day average. So that's the flow, an average flow from mid-October to mid-November. And you see a pretty similar story that in general, there are some normal conditions, but those tend to be below but near the median. And then a fair amount of your reds and oranges, which indicate flows below the 25th percentile, and the red being below the 10th. So very low flows across most of the state. And then those kind of light white would be sites that aren't ranked because of missing data, because they're either seasonal or they're starting to be in ice right now. So moving on to look at some select gauges here, the North Fork of the Shoshone coming out of the eastern part of the park. Looking at the last couple months, we saw a pretty good spike of flow in September with some rain and coming out of the system, and then things have kind of trended off back closer to the 25th percentile, and then a little bit of a recent bump in flow there in the last few days of November here. So with some rain or snow melting off, so flows have been elevated a little bit closer to the median at that location. But in general, since the peak of runoff, things have been closer to the 25th percentile than they have to the median. Moving over to the Powder River at Arvada. So here we are. Things are in that normal range, but they're been hanging out pretty close to that 25th percentile since the end of September. So yeah, things are right around that area. We've seen a little bit of bump and flow around the beginning of November, and then things kind of came back down closer to that 25th percentile there, and quite a bit different looking hydrograph than that more of a snowmelt driven system out of the Absarokas there, where you see that normal flows go down to essentially 0 CFS in August and September there. So it's quite a bit different system. But right now, things are below the median and close to the 25th percentile. So low flows on the Powder right now. Moving on to the Medicine Bow above Seminole. That on that day, it was showing a all-time record low for the site. So we see here, and kind of since runoff, things went pretty close to the 25th percentile. Flows dipped below the 10th percentile in August and September, and then have kind of risen back up here right around November 1st to be closer to the median. And then you see a pretty sharp dip in flow there recently. And so that could be part to some management, or it could be ice starting to form on that river. And then moving over to the Green River at Warren Bridge, pretty similar conditions as what we've seen elsewhere. After the peak flow, things have hung out in that below the 25th percentile, and it's been pretty steady there since June, and even dropping down into the 10th percentile here in September and October, and then a bit of a revival here in November with some precipitation moving through the system, and then things kind of quickly dropped back down without sustained precipitation. A lot of sites that have been hanging out below the 25th percentile are going to kind of go back there if they're dependent on a groundwater base flow that's been depleted by a long period of lack of below normal precipitation. So I guess you'd expect to see pretty similar conditions going forward without sustained rain or melting snow, which hopefully we don't have this late into the season, the melting snow part. Moving over to the reservoirs, it's, not a time of abundant water supply. So as you'd expect with that there's only been minor changes in storage across the state, plus or minus gaining a little bit of storage, releasing a little bit of storage, either for management or some evaporation that occurred. And most major reservoirs are hanging out in that 40-90% range. And some of that'll be because of water supply conditions, and the others because of management objectives to keep the water at a certain level to protect infrastructure. So that's all I have. Thank you, Tony.
Well, thanks, Aaron. So looking now at the forecasts and outlooks, we have Lance Vandenbogart with the National Weather Service up in Riverton. And Lance will also be doing our highlight of the month. So go ahead.
All right. Thanks, Tony. So looking at our typical Wyoming hazard calendar, you can see that we're finally out of fire weather season. With the snow in the mountains, we have been seeing some increased prescribed burning, but winter storm related concerns and high wind concerns, those are our primary weather things that we have to deal with this time of year. So go ahead and look at precipitation forecast here for the next 7 days. So this covers through Thanksgiving, and we've got a decent amount of moisture coming into the mountains in the west, also the mountains in the south. There's going to be a weather system coming through this weekend that will hit the western ranges there, and then the southern ones will be later next week with the flow pattern, some moisture coming in through the south. But pretty dry for a lot of the basins and lower elevations, unless you're in one of those mountain valleys with near zero or less than 1/10 of an inch in those light green colors covering most areas. And then looking the week after next, what are the outlooks saying? You can see here on the left, a lot of shades of blue, nothing super confident, but the northeast, it is likely that it will be below normal temperatures. And then a lean towards cool also for the southwestern portion of the state. As far as precipitation outlook goes, there's a slight lean towards wetter than average, but not a major signal there. So it is going to be near normal, or just maybe slightly a better chance of being above is what is being shown there. So we're going to take a little pause. Instead of going right into the 1 month outlook or the 3 month kind of seasonal outlook, a question had come in over the last month about El Nino and La Nina and what the current phase is. So we'll take a little bit of time to talk about that. And when you hear people talk about El Nino and La Nina or ENSO, you might hear that's the more general term. They're describing an interaction between the ocean temperatures and what is normal and how that interacts with the atmosphere. So those graphics are showing some fancy arrows and colors. The point of this slide is not to understand exactly what's going on there, but just to realize that the Pacific Ocean covers a massive portion of the globe. And if the temperatures on the ocean are warmer or colder than average, that can affect on average where the jet stream is. And the jet stream, you may have heard me say this before if you're a regular listener, the jet stream is kind of like the railroad tracks that all the weather systems ride along. So if you're modifying where that jet stream is, you're going to be modifying how much moisture, how many cool systems are coming into your area. So El Nino and La Nina and ENSO aren't the only things that affect that jet stream and affect the overall weather pattern, but it is a major player. So you'll sometimes hear climatologists, or probably more often the news or some other source mention, oh, it's going to be a strong La Nina. And some folks are dialed in enough to their area that they might know what that means, but it's kind of hard to know exactly. So let's go ahead and step forward here, and we'll talk about the best way to kind of understand what's going on when you hear talk about El Nino or La Nina. So the point of this slide is not to describe exactly this graphic, but real quick, I can just tell you that those bars are the predicted percent chance that we'll be in that phase. So This is a current graphic, and you can see there it does a 3-month kind of running mean for those 3 months, and La Nina is favored for this winter. So you may have heard news or talk about that. But most people, they haven't lived in a place long enough or really studied this in depth enough to know, oh, okay, so it's going to be La Nina this winter. This is what this means for me. So if we step forward one more slide here, you can see that there here at NWS Riverton. So I'm a meteorologist, and my expertise is in the next 7 days. So I'm not a climatologist expert, but we happen to know some that work out of our DC office, and they cover the whole United States, and they look at things not only El Nino and La Nina, but they also look at things like the Arctic Oscillation. You might have heard of the North Atlantic Oscillation, the Madden-Julian Oscillation. So there's a lot of oscillations and different interactions between the oceans and the atmosphere that go on across the whole globe. And they try to condense this down to one easy to understand map. Now, the map does have some challenges in understanding it. So we'll take, not quite yet, but we will talk about that next. But I just wanted to show here, instead of focusing a lot on exactly whether it's going to be a La Nina or El Nino, you'll often hear me speak to these, 1 month or 3 month outlooks or the seasonal outlooks. And that's going to be where you can try to figure out for your area, what are all these different oscillations and atmospheric patterns and ocean patterns? What are they going to mean for me? So let's go ahead and step forward and just talk about how do we understand these graphics. Sometimes I kind of breeze through this and it might be a little bit confusing, but if you're trying to understand something like there are above normal chances for below normal temperatures, at first listen, that's like, what are you talking about, Lance? So let's look on the left-hand side of this graphic here, and we'll talk about a weighted coin flip. So the default outcome, if it was not a weighted coin, would be 50% chance heads, 50% chance tails. So that's what we might call equal chances of both. But if you knew some additional info, like you knew it was weighted towards tails, you might be able to modify that percentage and say 40% chance heads, 60% chance tails, and you might use something like leaning towards tails, or it's likely going to be tails. Now, if we shift gears in it, we actually talk about these longer term seasonal outlooks on the right-hand side of the slide here. You can see that instead of having 2 categories, when we're doing long-term weather outlooks, we actually use 3 categories. So we have we divide it into thirds. So a third of the time it'll be above normal, a third of the time it's near normal, and a third of the time it's below normal. That's what you might call equal chances. So there's no signal in the global climate system at that point. And near climatological or 30-year averages, that's your most likely forecast. That's your most likely bet. So if you look at the 30-year average for November 21st, if we were in equal chances, you'd want to go with the average high and the average low as far as predicting what it'd be like today. Now, if you have some additional info, and maybe that's okay, it's going to be a La Nina winter, well, then you can start doing correlations and see how does the jet stream usually, where does it sit? Where does it set up for the winter when we have a strong La Nina? And you might be able to modify those odds, and maybe you have something like a 45% chance of being below normal. Now, 45% chance, that's a long ways from being certain. So I won't want to put my life savings and bet it on a 45% chance. However, that is better than the default 33% chance. So we might say something like we're leaning towards below average, and that would be a colder than climatology being your best forecast because of La Nina. And we're kind of making up the scenario here, but let's say that La Nina ends up meaning below normal for this location. Well, then you are getting some information from that global climate system. So that was a lot of explanation. Hopefully that made sense. We'll jump into the actual outlook now, and we can take a look to see what this looks like live. So not super exciting here in the 1 month outlook. So this just came out today, and we're talking about December here. So the next month ahead, not a lot of information in the global climate system for the next 30 days for temperature. Maybe there's a slight lean towards a better chance of above normal in the far south, but that's right on the edge of there being really near climatology. So I wouldn't make too much of that. Same could be said for precipitation. Your 30-year averages are probably going to be your best over the month of December, save for Yellowstone, which, there's maybe a slight lean towards above normal moisture there for Yellowstone. If we go ahead and move forward to the winter outlook, not much changes as far as temperatures go. There's maybe a little lean towards cooler than average across the far northern part of the state. But there is an interesting signal in precipitation. So a lot of times when you go to this 3-month outlook, equal chances is probably your default. But because of the strong La Nina, along with these other factors that have been taken into account, all these other oscillations in the global climate system, there's a likely chance, which is that green color there technically is a 50 to 60% chance of above normal precipitation for Yellowstone and kind of the far northwestern mountains of the state. So something, La Nina is affecting the average position, or is I should say is forecast, or the outlook is showing that it will probably affect the average position of that jet stream and cause additional moisture across western Montana and into Yellowstone there. So we can gather something from the global climate system. Certainly, it's fun to talk about La Nina and El Nino, but I would direct people, whenever I get that question, I do direct them towards these graphics that are handled by people much smarter than myself, and they have a lot of expertise in looking at the climatology and what else is going on too, because maybe you have a strong La Nina, but there's another signal in one of those other oscillations that's counteracting that. Well, if you're just talking about La Nina patterns, that doesn't, you don't really know that that's going to happen. So it is worth looking to the experts and getting these updated charts. The seasonal outlooks do get updated twice a month, so they can be helpful to use for your long-term planning purposes. All right, I think that was the last slide there as far as my usual. I do want to talk to you all about the highlight of the month. This month is going to be probabilistic snow forecasts. So we are getting well into winter now, and we in the Weather Service here, we do have a tool that you could use that hopefully gives you some confidence in making decisions about snowfall, how much you're going to get, and the impacts you might have from that. So probabilistic snow forecasting, the probabilistic, that's kind of it's a catchy term right now. It is the future of weather forecasting, because the future is always uncertain. So just giving one number, like, next week we're going to get 3 inches of snow on Tuesday. That's not the reality of the situation. The reality is that there's a range of possibilities, right? And we all know this, that a snow forecast, even when it is a fairly big range, it sometimes falls outside of that, and it is a hard variable to forecast. However, we do have about 100 weather models now in the short term that we can take into account all their different opinions on what exactly is happening in the atmosphere and how much snow is going to be squeezed out of those clouds. And we can give a range of possibilities. So we call this ensemble forecasting or probabilistic forecasting. Those are those key phrases that you might hear. This particular type of probabilistic forecasting that we're doing for snowfall amounts right now, it just covers snow in the next 3 days, so 72 hours worth. Here's an example graphic. This was actually from a couple years ago in November. And you can see here a weather system coming in and affecting the western mountains of Wyoming with Jackson. Let's say if you look to kind of Jackson Hole in west central Wyoming, 9 to 14 inches. Now that's the expected snowfall range. That's kind of like the middle 50 percentile. So there's a 25% chance of falling below 9, and there's a 25% chance of actually getting more than 14 inches for Jackson with this event. On the right side there, you're not going to be able to see this, so I'll actually talk about those. That's the high end amount and low end amount. But when you visit the web page, and we'll try and do a live demo in a bit, that's where you're going to find these other amounts. So you'll get kind of a worst case scenario as far as the high end amount, and then the low end amount is like, you can bet on this. It's probably going to happen. So let's step forward and look at a zoomed in view of those two graphics on the right. This is going to be a separate storm. This one was more recent. This was in April of this last spring. But I'll go ahead and just draw your attention for this one to, let's look somewhere. Let's look at Casper. That's kind of an interesting point there. So you can see, as far as the low end snow amount, there's 10% of weather models in this scenario that were putting no snow in Casper. So maybe the temperatures were going to be warm enough that it was actually creating rain instead of snow. Or maybe it was just a drier forecast there for those 10% of weather models. But you can see here that if you wanted to have high confidence, you know, there's a chance you might not get any snow. So you wouldn't want to make a decision that you know, you need snow to go sledding, or I don't know what you're going to do. But that's the low end amount. Now, if you move to the right-hand graphic, you've got your high end amount. Now, 10% of weather models out of those 100 or so, they're putting over 8 inches of snow in Casper. So that's a pretty wide range. And what you could say from this is that this forecast overall is a very low confidence forecast. You know, 0 to 8 inches. If I gave someone a forecast of, hey, you know, next week you're going to get 0 to 8 inches, they'd probably laugh at me and say, yeah, you weathermen, you can keep your job, you know, being wrong 50% of the time or something like that. The reality is snow is a very difficult thing to forecast, and the weather model, there's enough variability with this weather system kind of late in the season that the temperatures were going to be around 32 degrees, and there was a wide range between 0 to 8 inches for Casper. And even that, 1 out of 5 times it was going to fall outside of that range. Obviously, you can't fall outside of this range on the low end. You can't get less than 0 inches of snow, but there's a chance that you're going to fall out on the high end there, and maybe 8 inches wasn't even enough if it stayed a little colder than that envelope was showing. So that is how you'd use these kind of graphics. It gives you a range based on science, not just an arbitrary 4 to 6 inches, which, you know, that's not as helpful. If we're thinking there's going to be 5 inches and we just arbitrarily say 4 to 6 inches, that's not really based on the science. That's just giving a window of, you know, a little wiggle room as far as our forecast goes. So let's go ahead and step forward here. If you scroll further down on this resource, you can see on the bottom left there is the link for it, weather.gov/RAW/winter. So this is all from our winter page. And you can see that you can look at thresholds. So instead of looking at it as far as how much you're going to get, you can say, what's the percent chance we're going to get over X amount of snow? And is that 1 inch or 2 inch? Along the top there, you can see all the different amounts. You might have to squint your eyes to see all the little graphics, but you click them and they become big. In this example, I snapshotted the 1 inch of snow or more. And if we look over towards, let's look at Buffalo here and pick on them for a bit. 81% chance there of having more than 1 inch of snow. Well, if you were to click 2 inches of snow, that's going to go down, right? There's a lower chance of getting more snow as you click to the right on those graphics. And then if you scroll below those graphics, you're going to get a little table of, and this is in chart form, so it's less graphical. But at a quick glance, you can see some of our bigger locations, and you can actually right above that red circled where it says box plots, there's a county selection. So you can drop down that menu, and you could pick, if you know that you live in Fremont County, well, you can pick Fremont County, and it'll give you more locations around Fremont County with the exact percent chances of seeing more snow than you know, 1, 2, 3, 1, 2, 4, 6, and so on. And then there are bar and box plots available. I won't take time today to talk about those, but know that they do exist, and you would find those by clicking those buttons there that Tony's highlighting for us. Okay, I think I have one example of a zoomed in version of this. Okay, yeah, so this is a different scenario. This was from late October of this year, so just last month. And you can see that, let's go ahead and look at Riverton. This is probably a good time to just to say, if you do use this resource, the number for the little red dot is going to be to the top and left of the red dot. So Du Bois makes it pretty clear that it's 40 or 94% for Du Bois of getting 1 inch or more on the left graphic. And then Riverton is 70%. So that 70 does not go with Shoshone, it goes with Riverton. So it's a little bit confusing there. We had to do that just to, mainly the reason we had to do this as far as where to put those labels is because of Fremont County and you know, how the highway kind of lines up. Lots of people want to know Riverton and Lander both at the same time. And if we just say one of the two, then they start, you know, yelling at us. So anyways, just know that is a little bit tricky there. The numbers to the top and left of it, of the threshold amount there. Okay, I think that covers this resource. As far as the overview, please do check it out. we are going to try to do a little live demo here. We have a little additional time. So Tony, thanks for being willing to try and swap it over to the live version here. So if you go to that weather.gov/RIW/winter, you're going to get to this page here. Up near the top, there's some big blue tabs. And right now, the green one we have selected, it says probabilistic snowfall forecast. If you were to click those other ones, they're not as helpful. But if you want to click the ice one, Tony, just to show that it highlights green when you click it. So there, we actually don't usually do ice accumulation because here in Wyoming, we don't deal with this like we do on the southern plains. They do have to worry about that. But go ahead and let's go back to the probabilistic snowfall forecast. So that's the tab we have selected. And there you go. So this is live data. So if you go ahead and click one of these graphics, it should pop up a new screen. Let's go ahead and try that. Okay, yeah, so it stays on the website, but it pops up this little, it makes it bigger so you can kind of see what's going on better. This is your expected snowfall forecast. So this is that 25th to 75th percentile. So 25% of the time, let's go ahead and pick on Jackson again. They've got a trace to 2 inches of snow. So there's a 25% chance of getting less than a trace, so basically no snow, and a 25% chance of getting over 2 inches. So that's our expected range, but half the time we're going to fall out of that. So if we want to know what the high end and low end are, in the top right there, there's a little X. We can close this graphic, and then we'll go back to the main page. And let's go ahead and see, okay, worst case scenario, if more moisture comes in than we were maybe initially expecting, well, Jackson has a chance of seeing 4 inches of snow. And there's a 10% chance that they might even see higher than 4 inches of snow with this weather system. So, if really bad things happen in your life at 5 inches, you could be like, okay, there is a 10% chance that we are going to get over 4. I should prepare for that, whatever it may be. I'm making up scenarios here, but that is kind of how we view this as being helpful. So let's close that one and we'll quick look at the low end, and then we'll scroll further down the page. So here's the low end. So there is a decent chance, less or a 10% chance of getting less than 1 inch. And we saw that from the other graphic, it actually labeled it as trace, but it could be next to nothing as far as 10% of those 100 or so weather models are saying Jackson itself is actually not going to get any snow with this system. Let's stay on this graphic just for a second. A key thing to look at is the valid time, and that's going to be right under the title. So this is valid from 5 a.m. Saturday through 5 p.m. Sunday. That time frame is chosen by us, and we try and it can't be more than the next 72 hours, but we'll shorten it up if there's snow coming in a certain day. That might only be a 24-hour period. So do look at that every time so you make sure that you're not thinking that this is coming in tomorrow, when in reality it's Saturday morning through Sunday evening that we're really talking about here on this graphic. Okay, we can close this one, and let's scroll a little further down and just quick look at those exceedance graphics. So here's this weather system, and if we go ahead and look at the 0.1, that's kind of like our trace amount. Technically, that's not a trace. We call anything less than 0.1 a trace. 0.1 is measurable snow, but this is just letting you know, okay, where is there going to be at least some snow, even if it's just a dusting. And you can see with this upcoming system, again, 5 a.m. Saturday through 5 p.m. Sunday, that's right under the title, there's a less than 10% chance that Riverton and Shoshone are even going to get a dusting. So this is really more of a western mountain, and even the southern mountains there get hit pretty good. Not every location, like if you're going to ski at Jackson Hole Mountain Resort there, just to the northwest of Jackson, we don't have a red dot, but you can look at the colors and you can see it's in that 90 to 100% dark blue color. So a pretty good chance of getting that amount of snow. Now, if we let's go all the way to 4 inches to see what's our chance of getting 4 inches. You'll see that that's notably less. So there you go. So Jackson itself does have a 15% chance of getting over 4 inches. And the Tetons there right next to it looks like they have about an 80% chance, 80 to 90% chance of getting over 4 inches with the system coming in this weekend. But then everywhere else, a lot of those colors dropped off, right? Because the chances are lower that this system is going to outperform to that high of a degree. Okay, let's see. If we scroll down a little further, I think the last thing is we talked about those charts, and Just mention that there. If you want to select, let's go ahead and select sublet. Shout out to Pinedale friends. And there we go. So you can see it has a lot of locations across the county. And for this upcoming event, it's the same time frame as before, which is listed here in the little blue box right above where it says county. But we're talking 5 a.m. Saturday. Let's see here. This one actually says 5 a.m. today until 11 a.m. tomorrow. So that's kind of interesting. That might be an error because I think it's all linked to the same data. So I'll look into that. That's good for me to know. Let's scroll down and just take a look though. So for this system, because that's what that label should say, you've got what are the chances of over 2 inches of snow? Well, you can see the highest chance for over 2 inches, Green River Lakes. That makes sense. So if you're up in the terrain there, that's the best chance of getting your over 2 inches of snow, along with any higher amounts as well. It seems like they're the winner in all the different categories based on these probabilities. So thank you for your time listening. I don't have anything else. I'll turn it back to you, Tony.
Thanks, Lance. Very, very interesting and a very helpful tool. And invite you all to check that out. And let's see if I can get back to here without causing an absolute disaster. There we go. Wendy, it's all yours.
All right, great. Thank you, Lance, Tony, and Aaron for presenting today's webinar. I just want to draw everyone's attention to this last slide. If you have any questions or follow-up for Tony, Aaron, or Lance, you can find their contact information on this slide. And also want to make note that we, as always, will not have our webinar in December. We always skip December. So to mark your calendars for January 16th for our next webinar. I also want to draw your attention to the chat where I dropped the link to the URL that Tony and Lance were just going through on the probabilistic snow tool. So with that, I'm going to go ahead and thank all of the attendees as well as the presenters for today's webinar. And here in a moment, we'll transition to Q&A.